So, good evening, one and all. I am Dr. T. Hari Prasad, working as a professor in Mechanical Department, Sri Vidyaniketan Engineering College, Tirupati. So, today I am presenting my paper that is optimization of the performance and emission characteristics of dual fuel diesel engine using LPG as a fuel. So, in this work, we converted a diesel engine into dual fuel engine, and uh, and we optimize the parameters of diesel engine using various optimization techniques. So our work will be the main objective of our work will be to find the performance and emission characteristics of dual fuel diesel engine. And once we got the emission characteristics and performance characteristics, then by using various optimization techniques to optimize the performance and emission characteristics using Tagu. One is Taguchi-Gray relation analysis, and one is regression analysis using Jaya algorithms, and one more is adaptive neurofuzzy interface systems using Jaya algorithms. So the next one is this is the engine we have considered for experimentation. So actually the engine will be 5 HP engine. So we converted into modified into dual fuel mode, where no we connected to LPG. LPG will be stored at very high pressures. So with help of mixing chamber device, we brought into atmospheric conditions. Then we injected that LPG into intake manifold, so that whenever engine is breathing, it will be breathed natural air as well as from LPG also. It will be taken into the consideration. So next one is we used ANVIS model that is called as adaptive neurofuzzy interface system. One is it is a combination of self-learning property of artificial neural network ANN, as well as the reasoning ability at fuzzy interface systems. It will be there. Next one is this ANFIS model will consist of different layers. One layer is called as fuzzification layer. The fuzzification layer is layer one. Adaptive nodes of this layer can convert input parameters into fuzzy values with the following equations. Next one is second layer will be called as a product layer. So here node in this layer is to calculate firing strength of the rule. This is the rule given by the firing strength of the rule. Third layer will be called as normalized layer, where normalization of the firing strength ith node is calculated using the following formula. Next one is fourth layer is defuzzification layer. And so in this layer, defuzzification layer, defuzzification to convert fuzzy values to predict the accurate parameter values. All nodes are adaptive nodes with the corresponding node function. And this layer will be calculated like this. And next one is last one is output layer, that is called as layer 5. The output layer, single node in this layer calculates the output value by adding all input signals as follows. So the output value is calculated based on all the signals like this. So this is about the ANFIS model. Next one is here we used a flowchart of the J algorithm. So the J algorithm we have used, and this is a flowchart. So initially the initialization of population size, number of design variables, and determination criteria will be there. So here afterwards it is identify the best and worst solution in the population. Next one is modified the solution based on best and worst solutions. Now that will be calculated. Is the solution corresponding to the this x values better than that of the corresponding values? If it is yes, no, accept the replace the previous solution. If no, means keep the previous solution as it is. Will be there. Next one is the termination criteria is satisfied? Yes means report the optimum solution. If not means we'll once again repeat the same condition. So like this, J algorithm will be working. Next one is this is the experimental data. Actually, this will be 5 HP Kirloskar engine, where we used diesel as one fuel, and LPG also as the secondary fuel. So where diesel will be used for ignition source and LPG will be used for combustion initiation and all these things. So for the diesel engine, we varied the injection pressure from 180 bar, 210 bar, and 230 bar, and LPG flow rates will be taken at 1 LPM and 1.5 LPM and 2 LPM. And brake power load on the engine will be varied from 1.1.3 kilowatt and 1.68 kilowatt and 2.2368 and 2.78 and 3.33 kilowatts. And these are the results of the various at various conditions. The various here one is brake thermal efficiency is there, one is HC emissions will be there. CO emissions will be there, and NOx emissions will be there, and smoke meter will be there. So here we used the smoke meter and exhaust gas analysis to find the efficiencies and to find the emissions and as well as smoke and all these things with help of smoke meter. And brake thermal efficiency will be brake power developed divided by MF into CV will equal the brake power, and brake thermal efficiency is brake power divided by MF into CV will equal the brake thermal efficiency. So like that we calculated the number of output parameters will be one is brake thermal efficiency, HC, CO and NOx and smoke. Now based on this data, we developed one matrix that is 3 by 3, three input variables in 3 levels, so that total readings will be comes around 27 readings will be coming. Next one is we used a mini tab software for optimizing using the Taguchi-Gray relation analysis, and these are the effect of various parameters on the output. This will be the effect of parameters on the brake thermal efficiency. So how the brake thermal efficiency varies with respect to input parameters, it is given. Similarly, brake thermal efficiency will be always tend to increase in all the graphs it is shown. Next one is effect of parameters on HC emissions is given. So here the various parameter injection pressure, and next one is LPG flow rate, and brake power is given. So all these conditions, how the brake HC emissions will be varies will be analyzed here. Similarly, effect of parameters on CO emissions, how the CO emissions will be varies with respect to variation in the input parameters will be. By seeing this graph, you can understand. Similarly, effect of parameters on NOx emissions will be, it is calculated based on the different input parameters. It is by showing this graph, you can understand. Last graph is smoke. How the smoke will be varied with respect to various input parameters. Variation is also shown here. So this is a graph. These are the graph which represents variation in the input and gives output values. Next one is we used gray relation analysis using Takochi, and we have given the ranks for all the categories, and we got the optimum condition parameters will be found for 180, 180 and 180, and next one is 1.13 brake power and 1 LPM will be there. There you will get the optimum GRG will be around 0.827917 will be there. So this is using gray relation analysis, that is using Taguchi method. Next one is we optimization using regression analysis using J algorithm. So we developed the relation between the various input parameters for GRG based on this regression analysis. No, based on this equation, we found that the optimum parameters for found to be 180 bar and 1 LPM and 1.13, and the optimum GRG is found to be 0.827917 will be there. Next one is to comparison of optimization of using ANFIS model and J algorithm will be. No, so if you compare means the results will be almost similar. So if you see the fitting of the curve also, target versus output will be there. So the R value will be around 0.994905 will be there. Similarly, optimization using ANFIS and J algorithms will be there. So if you use J algorithm, the optimum parameters will be obtained found to be for 194, 1 LPM and 1.13 brake power, and the optimum GRJ will be 0.835084. So if you compare all the results, no, if you, one is Taguchi Gray relation analysis, one is regression analysis J algorithm, and ANFIS J algorithm. No, so the optimized conditions for running the diesel engine will be almost similar with conditions will be there. But if you see ANFIS model will be giving the very accurate results, and also we tested actually at 190 and 210 and 330, but the optimum conditions are obtained at 194 bar and 1 LPM and 1.13 kilowatt brake power, where we'll get the optimum conditions. So in the totally what I conclude is, so we have done experiment on diesel engine, and we run the engine with the dual fuel mode. One is diesel engine and one is LPG. So diesel engine will be working as like any other engines, where and we convert to LPP with help of a fuel mixing chamber, and LPG cylinder will be there. So generally LPG will be stored at very high pressure. So we brought it to atmospheric condition through mixing chamber. Then it will be injected to the engine through inlet manifold, and then it will be breathing will be as usual, just like any diesel engine. Then we operated the engine at constant RPM, that is 1500 RPM, and Then we varied the load break power, injection power, and the LPG flow rates. And we got the results like 27 readings we have taken 3 by 3 level matrix. 27 readings we taken. So those values now we optimized using Taguchi gradient analysis and regression J algorithm and ANFIS J algorithms will be we have used. The softwares we used will be one is Minitab and MATLAB we have used for this optimization process. Then finally we'll get the optimized conditions where the efficiency is maximum and emissions will be minimum will be 190 1.13 and GRG value will be 0.82719 and this will be with respect to regression J algorithm and this is with respect to ANFIS J algorithm. So if you compare all the optimization techniques, ANFIS J algorithm will be giving very accurate results. So this is my work and this is my conclusion. Thank you, Vandala, for giving this opportunity. I thank you. Thank you all.